Hi, I'm Gary Katz. I want to thank all the folks who bought copies of my DVD programs over the last 20 years. If it wasn't for their support and the support of companies like Windsor One and Stabila, I never would have been able to produce what turned out to be a 10-program series on mastering Finish carpentry. Those 12 to 20-year-old videos look pretty terrible compared to streaming video today. And that's why I'm no longer selling the DVDs. But the carpentry techniques haven't aged much at all. And that's why I'm making them available here for free. Enjoy.
Before I put the panels inside the frames, I like to fit the frames for each wall so that the ends are cut just right. It's easier to handle the frames when they're empty, and besides, if I screw one of these up while I'm cutting it, I won't have to make all the panels over again too. We'll get to the panels and the molding next, but let's start with this first frame. I set it on a shim right here so it comes right up to the mark I made from the laser line, and now I'll shim the other corner. I'll put this end up on a shim too, so I'm pretty close to the chair rail height, and I'll butt this piece tight up against this back band here and scribe it to fit. I'll spread my scribes just as far as I need to. I just want to take a minimal amount off here. If you don't have a back band, here's a technique that makes this kind of a scribe a little easier to pull off. I'm going to pull this out of the way. You can just slide your board back as far as you can and put a square in here, and it doesn't matter how far you take it back. If your casing's perfectly flush to your frame, you can set a square or a piece of 1/4-inch plywood in here, or anything straight, and run your scribes right off of that, so you can have something to rest your scribes against when you're scribing off of something that's perfectly flush. But in this case, I've got an easy situation here where I can just do a little scribing. You can see it's not quite tight right through here. So I'll run my scribes, and I'm just going to take a minimal amount off of this so I don't change the size of that style much. That'll do it to nothing. You can see I just went to nothing there, and I'll need to take just a hair off the bottom too. Let me run up this plinth too, and you can see the line zeroes out again right here. I'm taking a real minimal amount off of here. Remember, when you're tracing a scribe line, you can move your scribes this way and that way as much as you want, as long as you've got a shoulder to rest on. You can move your scribes like this direction, but you can't twist them. You have to be perpendicular to the surface that you're scribing off of. Otherwise, you're not scribing a line, you're just doodling. Okay, we've got that pretty close. I'm going to take this out of here and plane this now. If you just have a little to take off, you can take a low-angle block plane like this if it's real sharp and peel it back just a little at a time, but I've got a lot of end grain right here on this top style. It's going to be easier for me to use a power plane to take this off. This table works pretty good for just about everything you do with face frames. I can move these little outriggers around so I can catch these clamps too. Get this pretty secured so I can plane this. Now I'm going to use a Festool planer here. The Festool planer takes a larger diameter hose, so I have to switch hoses on my vacuum, and so some of you are looking at my boom arm here. You're looking at this kind of rat's nest of hoses. What's really happening is I've got both hoses hooked up here, so I can release my large diameter hose and hook that onto the planer real easy. And to switch them out, I just make a little adjustment right at the back of the boom arm there real quick, and now I'm ready to go. This is a pretty nice planer. You can control the depth of cut right here with the handle. And I'm going to be using that as I plane, but not that much while I'm moving the planer. I'm really going to be controlling the depth of cut with how I pitch the planer on the style. I'm going to be running it upside down so I can see the cut, which is really nice. That way I can see the cutter as it comes through the style, and I can follow my scribe line perfectly. Now you can't do that with just about every plane. There's some planes, if you try that, it's going to blow the shavings right into your face. I've done that for years, and that gets really hard on you. I mean, having all that sawdust in your face. But this is a lot easier because the planer is going to draw away all of the sawdust. It'll never get in my way. and I'll be able to see the line. It's a little bit harder to operate the depth of cut knob while you're planing. So, like I said, I'm going to run this and pitch the plane back and forth, tilt it toward my scribe line, and the more I tilt it toward the line, the deeper I'm going to cut, the more material I'll cut. And the less I tilt it toward the scribe line, as I tilt it back from the scribe line, I'll just be undercutting the style more. I won't be cutting to the line, I'll just be back beveling it more, which is a good thing because a sharp edge is going to make it easier to fit tight up against that casing there. Then I've got to plane this area right in here too where the plinth block was. And you know, some of this I think I'm going to be able to fix actually now that I think about it by tapping that plinth block a little bit. But I'm going to take some of this out because it did look like it was a little bit ragged there. So I'm going to turn the plane around the other way and plane from the opposite direction and just pick it up from the bottom. That's pretty close. Let's see how this fits. Let's see how close we got. Usually I have to do this a second time, at least a little bit. Look at this. I got really nice and tight to this plinth block. You can get right in there and you can take a peek. And all the way up here, I got very tight to this back band on the first try. It isn't that hard to do, and you ought to be able to do this with your plane and your scribes, the two of them. This isn't that tough of a thing to do. Now, if there is a little bit of touch-up that you have to do, and I frequently have to do a little bit of touch-up to these scribes, I can do that very easily with my low-angle block plane. This isn't a regular block plane. It's a low-angle block plane. The planer angle is really low to the sole of the plane, so I can shave wood off much easier, and I can even shave cross grain. So it's a real handy tool to have. I've got another one that is with my JLC outfit. It's a Lee Neeson, which is really nice to hold, but this Stanley only costs about 50 or 60 bucks. Make sure you've got one if you're doing any kind of trim work. So if I need to, I can take this out of here, and with this sharp edge, you notice how sharp this edge is and how severely I back beveled this. With this sharp edge, it's so easy to take your plane and just take a little bit off of here. I'll go in the other direction so I don't pop the top grain off, and just take a little bit off that end grain right there. And right down here you can see where I left my pencil line. I can take off the rest of that pencil line if I want to real quickly with the low angle block plane. We'll put this back in here. And that's really pretty nice. I'm going to put a nail up here pretty high. We're going to remove this, so I only want to put one nail in it. And I put it up here fairly high where the cove mold's going to cover it later, or the chair rail detail underneath the chair rail, just to hold this to the wall so we can work on this other corner. Now we're ready to work on this inside corner. And the next piece is right here. And remember, this has the 4-inch stile on it, so we've got some work to do on this one. Before we do anything with this inside corner here, which is what we want to do, we need to scribe some off of this. We need to figure out how much to scribe off of it, and that's going to depend on how we run this lap joint on the corner. I think this lap joint ought to cover the edge grain on this piece here as seen from that end of the room, because that's where the majority of people are going to be looking at this from the middle of the room. You know, I could run the lap joint this way, but then the edge grain on this board is going to show more. Let me show you what I mean. I've got a little mock-up here that I've cut, and I've made 2 different passes with my router just to check different depths. And you can see I've got a number 2 on the inside edges of those boards. I think that was the one that fit the best. So these boards just come together like so. It's a rabbet on both pieces, and I get a pretty nice flush joint there. And I want that joint to sit just like this. So you'll see this end grain only from the door over there, not from the middle of the room. From the middle of the room, you'll see this base grain. So it'll make a real pretty joint. So that means we want this frame here to extend a full 3/4 of an inch past this frame here. Maybe a hair more. Let's measure and see how far this frame's projecting past the corner. Inch and a quarter. It's right at an inch and a quarter. So that means we want to take off, we only want this to be 3/4, right? So that means we want to take off a 1/2 inch, and maybe a little bit less. So let's scribe off about 7/16 of an inch back here. If we take 7/16 of an inch off this back stile, that's going to make this stile 3.5 inches almost exactly. And that'll give us the perfect overhang. So all of our stiles will be perfectly balanced. So we'll do that right now. I'm going to set another shim under here, just so that's nice and snug. And we'll set my scribes for 7/16 of an inch, just under a half. You know, if it's a really big frame, I like to tack them to the wall first instead of just trying to hold them with my hand while I'm scribing. But with this little frame and these shims underneath it, and it's not perfectly flush right here. It doesn't have to be. This is a straight line. It's pretty close. So I'm just going to run my scribes down here and pick this up right now. Now that I've got it scribed, I'll take this frame back and cut it at my table. I'm going to cut this off this end of my table so you can see better what I'm doing. But before I do, I want to talk about shooting sticks a little bit. I used to do everything, not everything, but most of my straight cuts, I used to do with a shooting stick. I made them on all kinds of different lengths. This is one I made just this morning. These are great when you're cutting with a circular saw if you have to make a perfectly straight cut. Whether you're a pro and you've been using a saw for years or whether you're a homeowner and you're just getting started, you can make one of these really easily. And actually, let me tell you a trick I use. I take this guide here, the fence that's on the top. This is all just 3/8 plywood. You can make them out of 1/4 inch plywood or 3/8 plywood. It doesn't matter what thickness, but you need 2 pieces, one for the guide, one for the base. There's a third piece here that I've screwed to the bottom, and that's a fence. I could talk about that in just a second. I took the guide on the top and I used some 2P10 fast-acting glue, and I stuck it down to the base here and held it along with a pencil line that I set with a framing square just to make sure it's perfectly square. And then once the glue's set up, I put the screws in. It's really hard to try and screw something down to a pencil line without it moving, you know what I mean? So the glue really helps get it set, and then I use the screws to secure it permanently. Now, the fence on the bottom is really important because it's perfectly square to the guide that you put on the top. You can use one of these, and I'm going to clamp this down. I think what I'll do is I'll clamp my piece of 1x12 here down. And you notice I've got a little edge of the base here showing on the left side of this guide too. That's a really important feature on a shooting stick because that's going to enable me to take a spring clamp and stick it right on there. And that's what will hold this thing in place. Now, the first time I cut through this, notice how wide this is on this side of the guide. The first time I cut through this, I'm going to cut off about 3/4 or an inch of plywood off this edge. But that's expected. You want that to happen. That way, once you've cut through the plywood the first time, you have a guide that's perfect, set perfectly for that specific saw. And afterwards, you're going to be able to align that piece of plywood with a measurement mark and cut right on. Now let me show you how we do this. See what I mean? Now this guide, this shooting stick now fits this saw perfectly. Anytime you want to use it again, your saw blade is going to be right on the edge of that plywood. So for future cuts, we'll just slide this out of the way for a second. For future cuts, you can make a pencil line. And if you want to get really, careful about this, you can take a square. But the shooting stick should hold you square too. But if you want to be careful, run a square across here. Let me get that out of my way a little. Continue that line to the other end of the board. So now you'll be sure to have a square line, and just put your shooting stick right on that line. And then clamp it in place. So I'm right on the pencil line. And now I can cut without worrying. And the other handy thing about having a shooting stick like this is you'll get minimal tear out on the top of your board, because the shooting stick will help protect the top of your board as the blade comes up through the top of it. Now this one we got some chipping, but then remember, I'm using a blade here that's probably meant more for framing than it is for finish. But it's a good little saw, and it did the job for us, just to show you how a shooting stick works. I don't use shooting sticks too often anymore. I use a Festool saw guide rail, and it's quite a bit handier for really tough jobs, or even for easy ones. Let me show you how that works. Not long ago, I got tired of all that sawdust, especially MDF sawdust. And I was also tired of using several different saw guides, one for square cuts, one for 22.5-degree bevel cuts, one for 45-degree bevel cuts, because every time you swing the saw on the base, you're cutting a little bit more off of your shooting stick. So for a variety of reasons, and actually there were a few more than that, cutting sheet goods and stuff like that, sizing sheet goods before I had to run them through my table saw, which I'll be talking about later, I bought a Festool saw and a guide rail. And it's a little bit like narcotics, once you buy one, you get hooked and you just can't stop yourself. Well, we'll get into that a little bit later. With a Festool saw guide, I can make all kinds of angled cuts at the same time without cutting the guide. Let me show you what I mean with this style here. The first cut I want to make is going to follow this scribe line really close. So I'm going to put the guide just past the pencil line, just a hair past it, just in case it's not perfectly straight. I'll leave a little bit of extra meat, and I can plane that off with my little hand plane. Oh, did you hear that? This thing is so cool. It has a rapid clamp on the bottom of it, so you can adjust the front clamp to roughly to the width of your stock, and then just pull the trigger and clamp this thing tight to your board when you're ready to cut, and then it releases from back here. Oh, and another neat thing, when you have it retracted all the way and you pull on the release at the back of it, you can swivel this out of the way so you can store this flat against the wall. I mean, engineering. Okay. So I'm going to put this on my pencil line and set it so that it's just past the pencil line. Let me double check that. Yeah. I just want to be just a hair past that pencil line. I'll tighten this up. And now I'll make a cut along there. There's another thing I've done with all of my Festool tools, most of them. The planer has a different plug, but all the other Festool product tools that I use the same electrical cord. So I have a little Velcro strap that goes right onto the dust collector hose, so I can switch these out real quick, switch from one tool to the next. And I'll rotate this out of my way and keep my vacuum hose up here, and I can make this cut real easily. There's one other thing I have to do before I make the cut though. I have to adjust the depth of cut. And I got to be careful, because a lot of times, whether you're cutting on a layup table like this, or even especially when you're cutting on your MFT table, which is the table that this is sitting on, and you'll see that a little later, you don't want to cut in too deep or you're going to cut right through some of these sacrificial strips. So I want to adjust the depth of cut. Festools are all made in Germany, and they're all based on the millimeter on the metric system. And that's not for me. I don't know if I'll ever have time to learn that in my life. So what I've done here is I've made some trial cuts, and you'll notice that I've put these little marks on here that will guide me to the right depth. This one's for a 3/4 inch board, which I'm cutting here. Here's a mark for a 1/2 inch board, and here's a mark for a 1/4 inch board. And as I use this tool longer, I'll probably end up with marks all through here. But I had to have something. So now I'll just be cutting maybe a 1/16 and 1/8 of an inch more than the thickness of this board. I don't know if you noticed or not, but this is a plunge cutting saw. The blade's not exposed unless you push the button back here and plunge the blade down into the workpiece, which makes it an extremely safe saw to use because the blade's always protected by the guard. Not only that, I'm going to unplug this for a second and show you something else so the power is disconnected. When you plunge the saw, you push the green button up here and plunge the saw down. When you do, the riving knife at the base of the saw, see the little riving knife down here, is exposed. So you can see that you're always using the riving knife unless you're doing a true plunge cut in the center of a board, and I'm not going to get into that right now. But when you're making regular straight cuts, as soon as you start to plunge the saw, the riving knife comes down and prevents kickback, which is an extremely nice thing to have on a handheld circular saw. And you probably noticed when I made that cut, there is no dust. There's just no dust with this circular saw, which makes it really, really nice when you're using it to cut MDF. Now let's do something else. When I'm making this cut, I want to back bevel this scribe line, the scribe cut I just made. I want to cut it at a slight bevel like we did that last piece. The last piece we did it entirely with the power plane, but this one, since I've got the circular saw here, I may as well cut this a little bit of a bevel too. And remember I said before that I don't have to use a different saw guide for this operation. I can use the same saw guide and just tip the guide down, let's say to 15 degrees, and we'll tighten this up. And I can make the same cut and it'll still be on exactly the same scribe line. I'm going to hook the power back up, swing the hose out of my way. And now let me show you that scribe line. You can see here's my pencil line. Here's the little sliver I just cut off that's just sitting here. And that's how fine a cut you can make with this saw. It's definitely cabinet grade quality. Here's my scribe line where I left the pencil line, just a hair of it. And I left the pencil line up here at the very top. You can see I had to leave the pencil line right up here too. And that meant there's a little bit of belly left in here where my pencil scribe line is, and that I'll just have to take off by hand. And that's easy enough to do. I can do that real quick here. I'm going to slide this out a little bit further, get it just past my outriggers. I'll do that right here and just take that little bit off. And look, see, since I've got this beveled angle on here, I don't have to take a lot of meat with this. I can just work that scribe line right up to that end grain and watch how this little plane, takes off the end grain. Now we're ready to cut the rabbet on the leading edge of this frame. I've turned the frame upside down. The rabbet's always cut on the back for both sides, so this is really pretty simple. In fact, these bearing guided rabbeting bits, they make it really easy to cut nice joinery and wainscoting panels. And like I said earlier, you can get fancier with your corners, but I think these simple rabbets that we're going to cut here are plenty durable. I've got a bearing on this bit, so the bit's going to cut exactly a 3/8 deep or shoulder rabbet into this style. I've also adjusted the router so it'll cut exactly 3/8 of an inch deep. So it'll have a 3/8 shoulder to 3/8 depth. I'm going to test this setup right now before I make a critical pass on this piece here, just to make sure we're dialed in exactly. The router is a Festool router, so it's always in plunge mode, just like their saw in a way, until you lock it down. And there's something I want to warn you about. This has a pretty good dust collection system too. It all depends on this little dust port here that you attach to the base of the router. And what I want to warn you about is how you can cost yourself 14 bucks real quick. This is the dust port that I ran my router bit right through the top of when I released the plunge mechanism, and the bit came straight up while it was running. Came straight up one time right through the top of the port. Here's a brand new one I had to buy, and if you look at this, you'll see there's this little door on the port that you swivel open and you swivel closed, and that's how you get the port onto the bit. And what you have to do is drop the router down until the body of the bit is kind of flush with the router base, and then open the door on that port and just wiggle it around that bit like so, and then drop the port into place. And then the arm on the back, you just swivel the pin on the back and it locks the port into place like so. So now the port's exactly where I need it, and I can close the little door on the top. And that'll seal up the area around the bit. But like I said, be really careful when you release the plunge mechanism. Don't let that bit come up through the rest of that, through the top of the port. It'll just cut a hole right in the port, and you'll end up having to buy a $14 port. All right, let's cut a little test piece here. I'm going to make sure that I'm on the right turret stop, and it looks like I am. And I can check that too, but what we'll do is we'll run ourselves down to that turret stop, and I'll get a piece of scrap here and clamp this down so I can cut that. We'll just make a test cut on this piece of scrap just to make sure the bit's at exactly the right elevation. And I'll hook up the dust collector. Actually, you can use either the large diameter hose or the small one. The small diameter hose fits right inside the port. The large diameter hose actually works better with this router. I just have this Velcro strap on here, so it's quicker for me to use the same size hose most of the time. It looks about right. You probably noticed a couple of things here. First, I've been running this router mostly with the bit, with the rotation of the bit, rather than against the rotation of the bit. And this kind of goes against most of the rules most people have for routers. They always think you've got to run it against the rotation of the bit. It's the case probably 75% of the time. But when you're cutting rabbets like this, the first few passes you make, you really want to run with the rotation of the bit. And that way you don't have so much tear out right on the leading edge here. And that's really important. You don't want the tear out to be visible. And the other thing is, you probably noticed this crazy looking base. This is an extended base that I have here on this router. It helps me hold the router flatter on the workpiece. You know, this router has a tendency to tip a little bit because the weight of the hose and part of the weight of the tool is off the edge of the workpiece. So with that extended base, I can hold myself flatter on the back of the workpiece. And I didn't have this in place for that cut, and I'm going to put it on now. The extended base that Festool has for this router is a little bit different than the base that comes with the router. The base that comes with the router also comes with a chip catcher, just like this one, but it snaps into place, and this one doesn't. This one's magnetic, so it slips in and it fastens with magnets. You can pick up most of the chips from the bottom too, right up into the vacuum system. And now, let's check this piece, see how it fits. I'll cut the end of it off. And then cut it in half. Put these together. There we go. Hey, right on. Perfectly flush. So I got that set up right. I definitely wanted to check that before I routed the back of my frame here. And by the way, you probably noticed I clamped the frame to my work table before using the saw or the router. I learned a long time ago that clamps like these, all the clamps I'm using, they're really cheap. and they make it possible to really control your handheld tools and cut clean joinery. If you try to hold a workpiece with one hand and run a power tool over the top of it with the other, you won't experience the joy of craftsmanship. You won't get quality cuts. You'll probably screw something up, and more than likely you'll hurt yourself. It's really ironic how safe working methods and quality craftsmanship support each other. You almost can't have one without the other. Now let's cut the back of this frame, since we know that router's set up right on. You probably noticed that router tipped just a tiny bit right at the end, and it cut a little bit deep right in here, about 32nd of an inch. It's not bad at all, but we'll probably notice it when we check the fit. Let's go see what it looks like. We'll check this fit. Well, it's a little high because those shims are high, but that scribe is just perfect. It's right on. The scribe is nice and snug all the way down. And let's check this rabbet. And this is the way it's going to sit. So we need to cut a little bit off of this panel, but not very much. And we want to take some off this panel. As a matter of fact, we want to take some off the leading edge right here, because there's about 3/8 of an inch of this edge grain showing off this face frame. So we want to remove about 3/8 of an inch off of this face frame before we rabbet the back of it. And I can just make little drawings right here just to remind myself where I'm cutting. The rabbet's on the back of the frame, remember that. So I don't have to take anything off the rear end of this frame into this inside corner here, not a thing. And that's because the rules that I use for measuring the frames work really well. So we'll cut everything off the front edge of this frame. Now we'll set this up so I can take 3/8 of an inch off this frame to start with. Get those clamps out of my way. And I've got it set so that I'm doing all my cutting from the back of the frame. I'll just take my square and make a mark back here that's parallel to the front. Put one at 3/8 at that end, one at 3/8 at this end. And then I'll take my guide and I can set it on those lines. Switch the power and the vacuum over. Check my depth of cut. Get my vacuum hose up on top of my work table, and we're ready to go. Now let's check the fit on this. Oh, that's pretty good. We're just barely touching the wall back here, which doesn't matter anyway because this next frame's going to cover this back corner. But this joint's nice and tight. There's just one thing that I'm concerned about, and that is that this joint isn't perfectly flush. If anything, the face on this style here is a hair proud of this edge grain here, and I'd rather, if anything, it were the other way around. I'd rather have this edge grain proud of the face because it's easier to sand off this little strip than it is to sand off the whole face. It's hard to get these joints precisely the way you want them when you're using a single bit setup. If the wood is just a variance in width, if the wood varies in width just a little bit between this piece and this piece, or if you're holding the router a little bit different when you're mortising this piece, when you're rabbeting this piece or something, your cuts won't be exactly the way you want them. And that means I really want to take the shoulder on this rabbet. I want to take the shoulder on this rabbet right here and cut it just a little bit deeper, like right there. And I'm going to do that with my circular saw and guide rail on my table real quick. It'll only take a second to do. I'll put my guide rail right on this panel and just back it off from this rabbet, just a hair, oh, like a 1/16 of an inch, and then tighten it onto this board. Now there's one thing we have to be careful about. And if any of you have ever done this before, you probably know exactly what it is. We've got this saw set to cut 3/4 of an inch deep. If I go ahead and plunge through this, I'm going to cut that rabbet right off and I'm going to have to start over from scratch. I've done it enough times. So what I'm going to do is before I even plug this in, I'm going to drop the saw down onto that rabbet, and so I'm going to loosen this up just a little bit and slide this over and drop the saw down right onto the rabbet so I can see exactly what the depth of cut is. And now I know precisely how far I need to cut, and I can set the stop right at that depth. And if I want to be smart about this, I should make a little line right here, right? Because this is the one I'm missing. And that's 3/8. Little sliver out of our way. Perfect. Now we can set that frame. Now that's what we wanted. So this piece here is just a hair proud now, and I could fasten nails through this corner in this direction, nails through this corner in this direction, along with some good glue in that joint, and get a really nice tight corner. So we're ready to move on to the next piece. I think I'll take a nail gun right now and tack this in place so it doesn't fall over. We'll just tack these pieces to the wall so we can finish fitting everything. Now, let's look at several issues that are going on here. Come on in here closer and let me show you what I mean. Here's what I want you to look at. You notice how the top of this frame right here, where this face frame is, isn't touching this face frame. That's because something's out of plumb. And what is it? Well, it's got to be this wall, because we know this is set at the line of the laser, because we marked the wall. So this wall has to be out of plumb. It's a real easy thing to fix. We could take a shim. I happen to have one right here. We could take a shim and pull this frame away from the wall and shim it just like so and fix that problem completely. But we have to look at the whole picture. What would happen if we took that whole out of plumb corner, took it out with a shim right here? What's going to happen to the top of the chair rail? Are we going to see that at in the top of the chair rail when we finish installing the chair? And yeah, I think we will. If you look straight down at this face frame right now, you'll notice that it's out more than a quarter of an inch at this corner. So you'll see this top of this chair rail when we're finished, it'll have a taper to it. So I'd like to try and avoid that. So what I'm going to do is I'm going to cheat this corner. I'm not going to install these panels perfectly plumb and perfectly square. That's not my job as a finished carpenter. My job is to make everything look perfect, even though it isn't. My job is to make things look good, even though things aren't perfect, and things rarely are perfect on a job. So I'm going to back the shim out and just take out about half of that. And you know, that's what we call splitting the difference. I'm going to take out about half of that, and the rest of it I'm going to take out of the scribe when I scribe the back of this panel. Because remember, I'm going to take about 1/2 inch off the back of this panel. Before we do that, we want to scribe the opposite end, but I'm going to talk about that in a minute. There's something else I want to show you. Sometimes these walls are out of plumb in this direction, you know, where this one's leaning back at the top, and sometimes they're out of plumb in the other direction, where they're actually leaning forward at the top and there's a hole at the bottom. And what I used to do is I used to have to take all the frames off and get some shims back in there. Or later on, you know, about 10 or 15 years after I started doing this, I figured out you could run a drywall screw down there at the bottom and adjust that drywall screw in the drywall before you put the frame on. And if it wasn't just perfect, you could take the frame off and run the drywall screw in a little further or back it out a little further. Hey, there's a new way of doing this, and I gotta show you this. It's pretty cool. Let me pick this up. I've got it right over here. I just need a couple of things to do this. And I need my drill motor and one of these trim adjuster screws. These are made by Bill Shaw, the fellow that invented and makes the Cope Master. He's got these on his website, and you can get these from him. Let me take one of these out. These are really unusual, and I'm not surprised that Bill thought of this. These are square drive screws too. I've got a square driver in my drill motor here. It's a square drive screw, and it has a really long self-tapping bit on the end of it. And what you can do with this, and I'm going to put it in the top here just to show you, what you can do with these. And the hole I put in the top will probably be covered by the little cove mold when we're done. Normally in the top, of course, it's so much easier just to use a shim, but I want you to be able to see what these things do. I could put it in the bottom where it's meant to go for pulling out the bottom of the frame, but you wouldn't be able to see it so easily. So I'm going to stick it right in here in the top, and I'll move this frame out of my way for a second, and we'll just put it back here in the corner. I'm going to run the bit forward clockwise, the way you should, like a drill, just like you would when you're running a screw in or a drill bit. I'm going to run it clockwise, and then once the bit bottoms out and hits these threads, I'm going to reverse the rotation of the drill, and this adjuster will thread its way right into the frame here and come up against the drywall. So it's a really unique way of shimming something out when you can't get to it. And once you bottom out, you go in reverse. So it's adjustable. You can move the panel in and out anywhere you want. We've got the shim up at this end that we can use. So I'll take that out of there and save it so I don't have to buy another one and use it somewhere else. And all we wanted to do here was split the difference with this panel, and that's about right there. I'll scribe the rest of this off. But before I do that, let's talk about what would happen if this panel were already in place. If this panel were already installed and this one went in on top of it. Because that's another problem a lot of people run into on jobs. Let me put this frame in first so I can show you what I'm talking about. Oh, and before I go too far with this, I was just looking at these again and I forgot. Did I tell you what these are really meant for? They're meant for baseboard. Like when you have mostly coped corners on inside corners on baseboard or something, and the corners are just out of plumb or just out of whack or something, you need to close up a joint. You probably already figured that out. If you've had any experience trying to get little shims behind the baseboard, you know exactly what it's about. So let's get back to what I was talking about. Let's say this frame is already on the wall for whatever reason. Maybe you're matching the wainscoting in an existing home, or maybe you just started installing the frames in the middle of the room right on this wall for some reason or other. Anyway, The frame's already in place. Here's how I'd handle that. I'd bring in the other frame and set it in place. Now it doesn't have to be tight against this frame. In fact, I can hold it a quarter or a half an inch away because I'm not going to be measuring this frame to fit. I'm going to scribe it to fit. So let me set it about a quarter of an inch away, and I'll tack it. By the time we're done here, this frame's going to look like Swiss cheese, but I'll tack it right through there, and maybe the cove molding will hold that. Now what I want to do is I want to set it up for the scribe. See how the frame is overlapping this one by about a half an inch? The amount of this overhang here is all that matters. The gap back here has got nothing to do with anything. When you're scribing stuff, you're not measuring it, you're scribing it to fit. Keep your eye on the ball. This is all that matters, is this overhang, not this gap back here. Forget about how much you have to remove from this back stile. Your scribes are going to take care of that. In a minute, we're going to spread our scribes exactly the right amount, but before you do, you have to be sure that these two panels right here, this one and this one, are perfectly parallel. And the reason they have to be parallel is because these ends are already rabbeted. We're not going to be able to take anything off of there. We're not going to scribe these at all. So we're going to make them parallel right now before we scribe this back end. So I'm going to take this panel and I'm going to tip it up until it comes back flush. Look, I can use even this rabbet right here. All I have to do is take this rabbet and flush it up with the face of this panel, and they'll be perfectly parallel. So I'll put a shim underneath this one, bring it up in the air a little, and I have to go a little more than that. So I'll take this panel here and I'll just pull it away from the wall. I've got a tack in it right there. I'll just pull it away from the wall until it's flush too. So these two frames are flush right up the rabbet. I know that the overhang is equal now, and what I'm going to do is I'm just going to spread my scribes. How far do I want this to go? All I have to do is spread my scribes from the face of this stile, from the very face of this stile, to the back of this rabbet where we're going to want it to be when we're done. So I'm just going to take my scribes, spread them from the back of the rabbet to the very leading edge of that stile, right there, and then scribe off the back of this stile right here. Once I'd cut that stile, this whole piece would slip right into the corner and everything would fit perfectly. That's the way you'd balance the stiles and get a perfect fit. But fortunately, I don't have to do any scribing here. I'm installing all of these frames in the right order. I started at with this frame here, and I'm moving toward my left always around the room so that the second frame overlaps the first one on every corner. I'll fit this corner together later permanently with glue and nail and everything together flush and perfect, but not until I've got all the panels in. I'm just fitting the frames right now. Now let's fit this last frame, like I said, this long one that runs across the wall. I may have to scribe this in 2 steps. I won't know until I check that other end. And to do that, I'm going to have to pull this out of here because this panel's too long. I'm just going to slip it onto this shim right here for a second and bring it over to this corner and make sure I got it right at the right elevation. I want this panel up right at the mark, which is also the top of this back band that we've installed over here. I've installed the same back band on this casing and the same style plinth block to match what we did on the previous door. So I'll take this shim and I'll pick this up so this top rail is right at our mark. And then I think I'm going to pull this in slowly. I'm going to drag it off that shim, so I better grab it in the middle here. And I'll set this right up against that casing. And then I'm going to tuck it in as far as I can get it over here. Now, it's not going to go all the way in because this frame's too long. So I've got another shim here. We can put this under it, and that'll keep it pretty close. There we go. So we've got a shim down here to hold this flush just at the top here. The frame, you can tell, the frame's in here cockeyed. And this may look crazy, but this is the best way to do a 2-step scribe. The first thing we want to do is check and make sure that with the frame perfectly level at our marks that we shot with the laser, that this joint here is going to be tight. Now this slipped down, so I need to pick this up just a little bit. Right there. And this end is pretty close. Look at that. It could take a slight scribe though. About a 1/16 of an inch at the bottom to nothing at the top. You see that? And it looks pretty straight, but I think I'll run my scribes down it anyway. and I'll just spread them on just a minimal amount, just the smallest amount possible, and run them right down here. I could even take less than that off, but that'll do. And we'll just run a scribe line right down here. And I'll turn this around and grab the plinth too. So we're taking the least off the bottom, and it's kind of a tapered cut from nothing at the bottom to about 1/8 of an inch at the top, and there's a little bit of a belly in it right in here. You can see that little bit of a belly in here. That's it. So this will fit really well. Let's put this back in and check the fit on it. I probably said this before, but I'll say it again. Finish work has to be fun. If you're not enjoying yourself, figure out why and come up with a different approach. Use a different tool. Make a jig or a template. Do something so that you have more fun doing what you're doing. You notice I'm angling this in the other way this time. We angled it in this way the first time so that we could scribe this end, and we've already scribed it. And now we're going to angle it in the other way so we can scribe that end. But before I can scribe it, I have to do the same thing. I have to set it up for the scribe, which means it has to be level here, and it has to be perfectly level with this frame back here. So I need to shim that up a little bit too. There we go. And this is how much I've got to scribe off this panel back here. And oh, we were going to cheat this a little. So let's put a shim in here and pull this out a hair. And we'll split the difference here. That's what we were going to do. Now it's all coming back to me. Okay, I'm ready to scribe this now. And how much do I want to pull? How much do I want to spread my scribes? That's what we got to figure out. So I'm going to come on back over to this end. All I have to do is spread my scribes the amount that this frame is hanging past the back band. Because sometimes with a long frame angled in position like this, that's all you have to do is spread your scribes for the overhang, the amount that's hanging past the back band or sometimes past the casing, and scribe the other end. But if the frame isn't long or the angle's really severe, the overhang might not be a precise way of measuring how much needs to be removed. The safest way to do it is to move the frame out of the way. I'll use my laser distance measuring tool right off of the back band here and then hit that frame. That should do it. Yeah, we got our 3 numbers, 102 and 5/8, 3 times, perfectly. It's right on. The reason that these lasers are so accurate is because they're actually measuring the speed of light. This isn't like the laser we used to shoot that level line earlier when we were shooting our level line for the top of the wainscoting. That's just a laser beam at a level line. This is a lot more involved. What happens is when you turn on the laser and you fire the button, it also fires another laser line directly back inside of the instrument simultaneously, and that's what triggers it. And as soon as it's triggered, it measures the speed of light, how long it takes for that laser beam to hit the target and return. So it knows exactly how fast and how far it's gone. That's why it's accurate to within a 1/16 of an inch. There are very few distance measuring tools on the market today that have that degree of accuracy. So what I'm going to do is I'm going to take my tape measure and I'm going to measure from this edge of the scribe, which we're already finished with. We know this edge is good. Let me pull this out of the corner a little bit. I'll pull my tape from there all the way across this frame and make my measurement mark at 102 and 5/8 right here. And now, with that mark made, I'm ready to scribe this panel. And no matter what I do, I can't go wrong. No matter what I do at this point, I can't mess this up. This has to be level, and this end, once again, has to be flush too. So I'll pick up this frame and get it up in the air a little bit more so it's perfectly flush up here. And now all I have to do is spread my scribes from this frame to that measurement mark, and I'll be right on. This whole frame could be shifted that way an inch and it wouldn't matter. As long as all I do is spread my scribes from this frame to that measurement mark, this frame, once I cut it, will fit in here just perfectly. Well, that fits pretty nice and tight. And what if it didn't? What if it was a hair loose right here? I could always go back to this corner, loosen that prior panel and put some shims behind it, 1/16 of an inch or something, and move this whole thing closer to this frame. 1/16 of an inch, who's gonna notice that? Would you? Hey, now that we've got this fitting really tight, now it's time to do the panels. People think the Craftsman style panels are the hardest thing to make because there's no molding, but actually the opposite is true. It's so much easier to rabbet out the back of this frame, and that's what I'm doing. I'm using that same bearing guided rabbeting bit back here that I used on the outside style joints. I've just changed the setting on the turret stop, so I'm not cutting quite as deep. I've set a second stop here, and the rabbet's only 1/4 of an inch deep. And that way, I can switch back and forth between rabbets really easily. You probably notice there's also a lot more sawdust while I'm making these cuts. That's because I had to remove the chip catcher from the bottom of the router. When I make interior cuts like this around the inside of a frame, the chip catcher gets in the way. I run the router, like I said before, with the rotation of the bit for the first few passes. I learned that trick a few years ago from another JLC Live carpenter, Gary Ashburn. I was having trouble with the face frames chipping out, splitting out, and tearing out. And I think I mentioned this earlier when we were rabbeting the corners too. And he taught me this. You know, lots of people say you shouldn't run the router with the rotation of the bit because it can get away from you. And actually, doing it prevents tear out on the face of the frame. You just have to keep your hands on it. Hang on to the router and make sure it doesn't get away from you while you're making the cut. Take very shallow passes each time and rein in the router with both hands. Once you're gone around the frame a few times, then change direction and clean the rabbet out. All the corners are going to end up radius just like this from the router bit, but we'll solve that problem in a minute. Right now, we're going to get ready to measure for these panels, but I want to finish routing out the rest of this frame first. For those of you who are really paying attention, you might have noticed that between the last shot and this shot, I stuck some 1x boards underneath this frame so I could elevate it a little bit higher above my layup table so that the bearing on the bottom of the bit was no longer hanging up on these uprights. It sure makes it a lot faster. And you probably saw me again moving these clamps out of the way. It makes it really easy if you have uprights like this that are adjustable on the fly. This one measures 15 5/16. This one measures 15 and almost 3/8, a little bit more than 5/16. This one measures 15 5/16. This one measures just this, yep, this is the same, a little bit more than 5/16, almost 3/8. And this one is the same, almost 3/8. So let's figure their 5/16. 15 5/16, I'm going to subtract exactly 1/8 of an inch from that, and that's the smallest measurement. So we're going to make these 15 3/16. So we're exactly 1/8 of an inch shy here. Always make these measurements, all measurements, precisely, to within 1/16 of an inch at least. When you're doing finish work, don't be tempted to round stuff off to the nearest 1/8 of an inch. If you do that, when you measure for an outlet cutout or some other cutout like a light or something, all your measurements will be off. If you round stuff off, you'll never be precise. Your cutout could end up off by 1/8 of an inch or more. I'm sure some of you have had this happen before. Measure precisely and your cutouts will fit perfectly. And what I want to do here is I want to subtract exactly 1/8 of an inch for the fit of the panel from each dimension. And that's going to make the panel 15 3/16 wide, and we know all of these are going to be the same, by 19 3/4, so we're going to subtract exactly 1/8. That'd make it 19 5/8. So that's good. And I'm going to come down here and check these just to be sure once more. That'd be 19 5/8 if we subtract the 1/8. And this would be 15 and a strong 3/16 if we subtract the 1/8. So we'll just leave it like that. That'll be perfect. So now we're ready to cut all of our panels. We're going to rip them first, and then we'll cross cut them. I've got this sheet of 1/4 inch pre-finished maple plywood down here. I'm going to use pre-finished plywood for these panels, and I'll show you why in just a second. But I'm measuring off the end here the 15 3/16 that we got, which was the width of the panels. The height of the panels we'll cross cut in a few minutes. I just don't want to take this full 1/4 inch sheet and shove it through my table saw. I've spent so many years wrestling large, awkward sheets of plywood alone through my table saw. God, I don't know. About half the time I'm able to make the first rip safely and accurately, and about half the time I'm not. Sure, after the first rip, the sheet's usually a lot easier to handle, but sometimes the full sheet bucks while it's in the saw. Especially thin stuff like this, sometimes it can ride on top of the blade. It gets really dangerous. And besides, if that first pass is messed up, the whole process becomes a pain. You end up having to cut it straight one way or the other. I've said this before and I'll say it again. Finish work's got to be fun. If it's not fun, then figure out a better way of what you're doing. Let me get 15 3/16 on this side too. And now I'll set this guide rail right on those marks. Having a long one like this is sure handy. I'm just going to eyeball that one down there, but I'll put it right on this mark. I'm going to take these clamps. This is one of Festool's quick clamps, and I'll slide that in here. Bring the clamp up against the bottom, and I can just take this handle then. It's got a ratchet in it and tighten it up. Now this straight edge would probably stay by itself. See, it won't even slide on here because it's got rubber, strips of rubber on the bottom of it, high friction rubber. And because this saw is operated in a plunging motion, remember you have to push down on the saw to make it work, it really helps this guide stay in place. But I still use the clamps because I just don't trust it entirely. You know, lately after listening to a lot of other carpenters who work solo, I've taken to cutting sheet goods down to rough size before pushing them through my table saw every single time. I don't have to work nearly as hard. The cuts are much more accurate, and unlike most circular saws, with this saw, there's almost no dust. And, you know, that's a real blessing, especially when you're cutting MDF sheet goods. You may not have seen it, but on this side of the table, I used Festool standard clamp, and it's just a twist clamp on the bottom. So we'll make this cut, and before I do, I've got to check that depth cut, that depth gauge on here, and set it for 1/4 of an inch. And I'm ready to go. Yep, vacuum came on. That wasn't too tough. Now that I've got the first piece cut, I'll send the rest of this sheet through the table saw. In the casing and baseboard program, we used a portable table saw for ripping stool and cutting rabbets. In this program, we're going to work with another table saw. This one's a saw stop saw. You've probably read or heard something about this saw. The thing that most people write and talk about is the automatic blade break. So let's talk about that first. You can check out the video on their website, which shows a hot dog coming into contact with the blade, and the blade stopping like just instantly and dropping right below the table at the same time. The video, watch that video. It's a real jolt to the table saw industry. I think it's going to really change the way table saws are made and manufactured. The brake system's pretty miraculous. It depends on the capacitance and the conductivity of the human body. When a finger or any human body part contacts the blade, a drop in electrical current is detected by the saw, and an aluminum pawl is fired automatically up into the blade. The blade stops before it can barely nick your finger. Let me show you underneath this saw. Here's the pawl or aluminum block that's fired into the blade. It's mounted to this spring. Sure, when the pawl hits the blade, it ruins the blade and the pawl. And you have to install a new firing mechanism too, but you still have your finger or your hand. That's not the only safety feature on this saw. The saw stop is shipped with a standard splitter, this one, which has a blade guard, and it has anti-kickback pawls. I've removed mine. They usually sit right on these pins here. I take them off when I'm ripping things like this pre-finished maple plywood because they can tend to leave a mark on them. But the blade guard is so narrow that it doesn't interfere with thin rips. You can still get a pretty thin rip right against the fence here without having to remove the guard. But if you do have to remove the guard, it's really easy. Just lift the guard up, pull the throat guard out, and down inside the saw here, there's a single lever. You lift the lever, pull the guard out, and the saw is shipped with a riving knife. And that's something I'm going to talk about some more. Table saws are dangerous to use. One of the greatest dangers is kickback. That's when internal grain pressure squeezes a kerf closed right at the back of the teeth. And when it happens, a piece of wood can, and the blade spinning at that point at about 5,000 RPMs or more, a piece of wood can fire right out the front of the saw like that. Let me show you what I'm talking about. I'm going to put this riving knife in here and lock it into place. When you're ripping a piece of wood, if the kerf closes on the back of the teeth right back here because of grain pressure or because the piece has a bow or a twist or it's pressing somehow or other against the fence, it can squeeze right against the teeth on the back of the blade. And when that happens, that's when you get kickback. And that's probably why we're supposed to stand off to the side of a saw when we're ripping, right? I mean, you don't want to get hit right in the stomach, and besides, if you've got a piece of wood that has a miter on the end of it, it can really get you. But that's not the real danger of kickback. If you're holding your hand right here and using it as a feather board when you're making a rip, and kickback occurs, the piece is going to be out of the saw in a second, and your hand's going to be pushing on the blade. You can see guys a lot of times missing their small finger, like this one right here, or sometimes they're missing these two and they're kind of cut off at an angle, and that's probably why. They were using their fingers as a feather board right here in this area, which is like no man's zone. This whole area where the throat guard is an area where your hand should never go. Now, if you see someone missing the end of their thumb, that's usually because they were doing repetitive cuts late on a Friday afternoon and they got careless, reaching around the back of the blade to pull small pieces, little cut-offs or clear away the debris or something. And then one time, just one time, they reached in a little too close. You know, like a splitter, a riving knife will prevent most instances of kickback because the blade can't squeeze on the back of the teeth right here. The riving knife will prevent that from happening, and it'll prevent a lot of accidents caused by carelessly reaching around the back of the blade. Those two reasons by themselves should be enough to convince carpenters that at minimum, they should always use a riving knife on their table saws. And since I'm on the subject of table saw safety, never turn on your saw unless you have a proper push stick right next to the rip fence within easy reach. And by the way, this isn't a push stick. It may act like one sometimes, but it's really a square. And this isn't a push stick either. It's a hammer. You don't want to use this as a push stick. Now, this is a push stick that some people use. It's got this notch cut in one end. And when you're pushing material through the saw, some people use these and they hook them right on the back of the material and then they push the piece through. But if something happens and this notch slips off the end of the board, which direction are you pushing in? You're pushing the stick directly toward the blade. You can't use a push stick like this safely. If anything happens, your hand's going to end up right in the blade. Use a proper push stick, one that's shaped like this one, like this. It's a large stick, it has a really nice handle on it, and when you use it, you're back here, your hand now has control over this whole board. It's like turning your hand into a 1 foot long clamp in a way, but it's not a clamp. If something happens, it'll slip off the back of the board, and your pressure is pushing in this direction right over the top of the blade, not down into the blade. As soon as the stock, and let me complete this rip and I'll show you exactly what I'm talking about. You saw what I did. As soon as the stock reaches the end of the fence here, I pick up the push stick and I push the board through the rest of the way. My left hand is free then. I take my left hand and I reach all the way around to this edge of the board and just guide it against the fence gently. You don't have to push hard. If you press too hard against the material right here, at the very worst, you could cause kickback. At the very least, you could easily end up ruining your rip. You can cut material that's wider than the reach of your saw, but most of us have learned the hard way that you have to cut the outside edge first. You have to bring the saw through the outside edge and lift it up in the air first before you bring the blade to the back of the piece to finish the cut. If you don't, and you cut the back of the sheet first and then come all the way to the front, the back of the sheet will pinch on the blade and grab it. And you can lose a hand that way. I mean, that's when this sheet goes bam up into the back of the saw and makes that noise. It's a dangerous thing to do. If the material's wider than 14 inches, you can't lift it without the saw getting in the way. Let me show you what I mean. We'll take a piece of this paneling that we ripped. And remember, it's 15 and 3/16. If you take a piece of this and try and cut through it by lifting it up in the air, look, I can't clear the guard. I cannot clear the guard without lifting the guard up out of the way. And how can I cut through the sheet at the same time? So what you do then is you have to make a cut from one direction, and then you have to flip the piece over if you want and finish the cut with the face grain down or something, or you have to whirlybird the material or something. It's not really accurate, and it's not a fun thing to do, especially if you need to use a repetitive stop. I've got a repetitive stop here on the miter saw, and it'll work if I flip the material upside down, but then I'm cutting through the face grain and the end and the good grains down. I'm going to get more chip out when it's up, etc. So the best way to cut these is on a Festool MFT table, especially when you have a lot of panels to cut. I've got mine set up right over here, and let me show you how we do that. This is the Festool Guiderail, and it's on a hinge at this end. And set up this way, the MFT table can handle panels that are up to about 24 inches wide, and who cares how tall. And I've got a roller stand out here to support it. It's easy to cobble together an auxiliary fence too, an extension for cutting even taller panels. The guide here, the whole guide rail actually can be switched from running in this direction across the width of the table to running across the length of the panel for cutting even wider sheets. And you can buy a second set of stops. I have them installed here on my fence. You can see right here is one of them, and there's another one on the other side of my MFT table. So I can run my longer guide rail across the length of the table for cutting really wide panels, and using exactly the same hardware, just my longer saw guide. And you can also set two of these MFT tables side by side. They sell hardware so you can hook them together. And you can use them that way to make like a really big radius if you want to run a trammel arm, or just to cut really big panels, or if you just need a bigger surface to work on. There's really no limit to how you can use these tools. It's all up to your ingenuity and your imagination. I'm going to cut several of these panels now, and I'm using their repetitive stop as well. It's a little flip stop. And the cool thing about this is you can get several of these and mount them on your fence here. And if you're cutting different length panels or something, you can just flip one up and flip the next one down and just keep moving. I'm going to, this will be my first cut here. I have also a sacrificial piece of 3/8 MDO down here on top of the table. That's not there to save my MFT table. You're supposed to cut into the MDF table a little bit, 1/16 to 1/8 of an inch. But the fence itself is about 1/2 inch thick. So in order to use the guide rail, I've got to bring this 1/4 inch plywood up a little bit higher. So that's why I have this MDO down first. And I've got it clamped in place so it won't slide around. And that's what this whole setup's about. I'm only going to cut down about 1/4 of an inch just to cut through that panel. So that's the depth of cut. And I'm going to cut several of these for that panel. And let me check that measurement before we cut too many more. 19 5/8, that's exactly what we wanted. Check my measurement one more time. Yep. Okay, we got the 5 panels. Once you've got them all cut, bring them over to your miter saw and chop the corners off. When I swing this to 45, I've got a pencil line that comes up here that I put on my saw that I can line this sheet up with. And that way I can chop these corners off almost exactly the same. This is another really good time to have a hood on the back of your saw like this, because you saw those little pieces, a couple of them flew out. A real nice safety feature if you're working on a job site, these little pieces are little triangular corners, and when they fly through the air, they can catch somebody in the eye real easily. This is a lot easier cutting them this way than having to trying to square up all those radius corners with a chisel or something. Cutting 1/4-inch sheet material panels is about the easiest way to make wainscoting. And sheet goods are a good choice too because they don't expand or contract like solid wood does, which means you can, in most parts of the country, you can glue them in like I'm doing here. I'm in the Southwest in California, Arizona, I'm in New Mexico, a good part of the country, and probably even up into the Northeast you can get away with gluing in these panels because they're just not going to, the wood's just not going to expand and contract that much. They will expand and contract, and the styles will expand and contract a little bit, so you should be careful with it depending upon where you live. But definitely, you can fasten them into the frame real good without any concern for seasonal wood movement. I'm using a wide crown 18 gauge finish stapler. It's a good choice for installing panels. The staples are 5/8 of an inch long, so they won't come out the face of the frame. And they're really narrow gauge, so they have a really wide crown too. The other thing is, in case you didn't notice, this is all pre-finished stain grade material. This is maple and I just bought it pre-finished. You can finish it yourself before installing the panels, and I definitely recommend finishing the panels before you put them in if they're going to be stain grade, because that way you don't have to worry about getting in there and painting all those inside corners. And if you're going to paint the frame, like in this case, is a paint grade frame with a stain grade panel, you can mask off the panel pretty quickly and just paint out the frame. So I'll run some glue around here too. And just center that panel in there. It should be about 1/16 of an inch shy all the way around. That's ready to go. Now before I install this frame, I want to scribe the stool to fit. It's going to be a lot easier to do that now because I can attach some brackets to the wall instead of to the frame. So I don't want to put the frame in just yet. I'm almost ready to. And when I do, I'm going to put some liquid nails on the backs of these panels, on each one, so that if there's any bow or something or belly in the wall, you know, these are just held in with the staples, and somebody comes through and kicks one of these, it might break loose. And if I put some liquid nails behind each one, it'll act as a shim and an adhesive at the same time. But right now, I'm going to move this frame out of the way. I'll just set it over here. And I'm going to install a couple of brackets here. Right underneath where this stool's going to go. And I'll put them in, just about the stool, the same elevation as the top rail. I'm just in the drywall there, just so they grab something. It's easier to do this now because I can attach these brackets without worrying about putting holes in my nice new frame. As I said earlier, the stool in some colonial homes should be continuous between the windows. So I've cut a piece for this wall, so it's long enough to reach this corner, and I want it to lap over the casing on that end. But first I had to rip it down and cut a new rabbet so it would project the right amount over the wainscoting. Let me show you what I mean. When you measure for stool projection, always think about the bottom, not just the casing on the top where the casing is going to sit. The stool has to be wide enough to accommodate the top rail. Let's just pretend that this is the top rail. The stool has to be wide enough to accommodate that, and it has to leave a reveal from the cove molding. We're going to put a piece of cove molding on top of the top rail, and that'll have to be underneath this stool too. So you need to have the stool wide enough for both. If you're using a square beveled stool like I'm using here, just measure from the front edge. Just measure right from the front edge here. I needed a 2-inch projection to cover the top rail and the cove molding and allow for a 1/2-inch reveal. Actually, I can rip this stool off right at the back of this step in the rabbet. Remember, the back of the apron or the back of the top rail is the face of the drywall. Now, if you're using a bullnose stool like this one, you have to include an additional 3/4 of an inch for the bullnose. Once you've figured out the projection, be sure to add for the windowsill or the jamb. Sometimes the windowsill is back inside the wall, as in this case. Look, the stool in this case has to reach back over the drywall, the distance of the jamb extensions really, back to the window. And here, that extension looks to be about, it's 5/8 of an inch on this end and 5/8 on this end, so I'm going to make it 3/4 just to be sure I have plenty of material to reach that windowsill back here. I ripped this stool down already, and I've allowed for the windowsill and the jamb extensions. And all I've got left to do on it is actually put the self-return on it for this end, because the self-return has to be installed before I can scribe this piece to fit. I've cut the miter on this end to make a self-return, and I've got the self-return piece here I've cut too. If you have any questions on how to do that, then watch the Installing Casing and Baseboard program. But I'm going to put a little 2P10 on here. Oh, and before I do, we can see this rabbet here. You can notice I've ripped the stool down enough so that I've allowed some of the rabbet here, so I have enough to reach the sill on the window. That's to cover the jamb extension, and enough meat left here for both the top rail and the cove molding, and a little reveal. So now I'm going to put this little self-return cap on. I'm using 2P10 glue, and I'll put a little of the thick glue on the small piece, and then I'll spray the longer piece. Remember, this is the system we use to make sure we don't get the spray onto our fingers, because the activator sets off the glue very quickly. This is another one of Fast Cap's products. It's very innovative glue. If you haven't tried it, make sure you get a chance to. 2P10 means it's 2-part glue and it dries in 10 seconds. When it's really fresh, it's more like 2P2. It dries very quickly. So make sure you get all your ducks in a row before you put this together. I'm going to put my finger right back here on the long point of this miter and hinge this closed and squeeze that joint tight, and put my finger up here to make sure it's flush and apply pressure. and that will dry. You can see a little bit of squeeze out coming out. And that will dry in 10 seconds. Well, it'll set in 10 seconds. And while you're doing this, move your fingers around a lot. See, my finger's stuck right there a little bit. Move your fingers around a lot because that activator does set off the glue quickly. Once it sets, you can pull it off. You can see I left a little bit of squeeze out there. It dried immediately. And anywhere there's squeeze out, like there is on the bottom of this, just a tiny bit, spray that a little bit with some activator, and any loose glue, any soft glue will dry immediately. You'll be able to peel it off with your fingernail and take the excess off. It's just like plastic at that point. And now we're ready to scribe this to fit into that window. I've cut this piece of stool long enough so it laps over the casing about 1.5 inches. We've got the self-return already on this end, so I'm ready to scribe and notch the self-return so it'll fit perfectly onto the casing. Now, part of the reason I've got a full 1.5 inch overlap here is so that I've got room to self-return the little cove molding underneath the stool too. Now at this end, on the left side, I've left this just a raw butt cut because I can't miter it until after I scribe and cut the stool to fit tight against the wall. Because the stool is 3/4 inch off the wall right here, where it's sitting on top of the casing, I have to space it 3/4 inch off the wall here too. And I've got a shim here I'll put in here, and I'll measure to the sill on the window. It's about 1.25 inches there. And what I really want to match is right here. It's 1.25 inches. Let me push it out a little bit more here. The scribe line is really important. The stool has to be parallel to the window and the wall, and that's why I've got this shim in here to get it perfectly parallel. These brackets provide a good place to secure the stool so the scribe line can be traced accurately. I'm going to check that this stool is parallel to the window with my scribes too. Just one final little check I can make, because if my scribes are on, then definitely the stool is parallel to the sill, and it's got to be. It's the easiest way to do it. I mean, I could take the stool and just make it parallel to the wall, but then I may have to make some monster scribe across the sill, and I'd like to avoid having to scribe it for the sill as much as possible. Now, these ends right here, where I'm going to scribe this cut here, these ends where I need to make a notch don't have to be perfect. I'm going to make a mark right here where I'm going to make a notch at this corner, right where the drywall returns to the sill, to the window jamb, and I'll make one right down here too. These don't have to be perfect at all because when we put the jamb extensions on, they're going to end up coming down right on top of the new stool, and they'll cover up that corner, so it just doesn't have to be perfect. But I'll install the extensions after the stool is in place, and I'll install the casing after that. So we're ready to scribe this. I'll pull my scribes down, pull a little lead out here, pull my scribes down across the wall, and remember, I need to keep my scribes perpendicular to the wall, perpendicular, straight off the wall. I can lay them down this way, pick them up this way, and do that sort of movement, but I can't turn them this way. I can't turn them so that they aren't perpendicular to the wall. So I'll keep them perpendicular to the wall, and I'll scribe the face of this casing too, and I'll make a mark back here, right at the back edge of the casing where that cut's got to be perfect so that this piece comes right into the casing. And then I can come down to this end and scribe out this corner all the way across and both sides of this shim that I've got in here, and make a little mark here at this edge so I know exactly where to make this notch for the drywall. Now, we won't have to cut the back of this, hopefully, very much, because it should already be parallel to the sill on the window. Now let's take this piece to the table and cut it. I cut these long scribes, actually they're pretty complicated on this stool, with a combination of tools. A jigsaw works really well because you have to use one anyway to cut these notches around the window. And I use a little circular saw sometimes if I'm doing a really long cut, but in this case I'll stick with the jigsaw. As long as you have the stool clamped down securely to something so that you can keep two hands on the tool at all times, you'll be able to follow these lines pretty easily. This jigsaw is extremely smooth running, so it doesn't really low vibration, so it doesn't have a tendency to drift from the cut. Plus, it has very good control on the blade. It will not cut a bevel. It will not cut off angle while you're turning a corner or even while you're making a straight cut. It'll cut perfectly straight, perfectly perpendicular to the wood, which is a really nice attribute for a jigsaw. I'll finish these cuts up real quick, just making one at a time here. I've removed a couple of things from the saw. If you want to get better dust collection, be sure to leave the guard on the front, and it just snaps into place. And with the guard on the front, you can also snap in these anti-tear-out little jigs. These are sacrificial in a way. You'll go through quite a few of these, but they snap into the bottom of this base. And actually, if you have both pieces in, you get almost 100% dust collection out of this. But in this case, even the plastic shroud that covers the blade on the nose of the tool, it interferes with my being able to see and follow this scribe line real closely, so I've removed both of them. This area in right here doesn't look like I got close enough to the line, so I'm going to clean that up while I'm here. That's better. Now I'm ready to check the fit here. That's nice and tight right here against the casing where it really matters. And it's tight all the way along the wall here. And look at that, it's got a little rock to it. Right on the window. Because it's not quite tight to the wall all the way through here. And it's missing the window right here, which means there's a little belly in it. I can see it right now. You can see there's just a small belly in it right through this area in here. So I'm going to make a couple of pencil marks here from about here to about here. And I'll take that off with my hand plane. Like I said, I use a combination of tools to do this. And I'll start here by just planing the back edge of this off a little at an angle like we were doing earlier. Let's try that. That's much better. That's much better. A hair more in there will really do it just fine. Just actually just in this short space right in here now. There we go. That's a nice fit. This is ready now to get a miter in this end. If I had mitered this earlier, I would have cut half the miter right off, the part that really mattered. I can take this over to my saw now and cut that miter. And all we want is the long point of the miter, which is against the wall, because it's an inside corner, to come out right at the end of this piece. Perfect, right on. So I can take this and set it over here, and that's a nice fit. It's tight up against the jamb, tight up against the sill rather, tight up against the casing in the wall. Remember, the window casing that we put on is going to cover it right through this area here, but it's pretty snug up against the sill on the window, and it's snug all the way across the wall here. And we've got our miter all set to go to turn this corner. Now we're ready to install that wainscoting. So if you're doing this in your home, don't forget, on one of your jobs, put the liquid nails on the backs of these panels before you squeeze this up against the wall permanently. And don't bury any electrical outlets like I'm doing here right now in my studio. I'll be taking all of this off a little bit later. Matter of fact, to measure to these outlet cutouts, I'd have to pull a measurement off the back of the back band here. That's the only way to measure accurately. And then pull the same measurement off the back of the frame and make my outlet cutout right in the panel. But I'm not going to do that. Instead, I'm going to get this in here. And I'm going to pick this frame up so it's right on with the bottom of the chair rail, which is the top of the back band. And this corner here has to come up just a hair. And the baseboard will cover down here. And now the next frame can go on. And the corner at the same time. So I'll get these so that they're right on the line. Tack my line. Then I'll fire one nail through the frame just to hold it still, and I can shoot one through the bottom too. And I've got a nice tight scribe line in the corner there. Now I'll switch guns. This is a 23 gauge pin nailer, and it fires needle-sized pins, both brads, and it shoots headless pins as well, up to 1 3/8. You can also buy one of these Cadex guns that'll shoot up to 2-inch brads and pin nails in the 23 gauge size. And I'm going to use a 23 gauge gun right here to fit this corner together. And be sure to glue these up too before you fasten them. And I'll get this nice and flush, and that way you won't even see these pins in this joint. They're so small, you don't even have to worry about filling the nail hole. And I can cross nail this too. While we're right here at this corner, I ought to tell you, look, if you take the time to fit all the frames correctly the way I have, the installation is pretty easy. It's just a matter of following the laser line and keeping your scribe corners tight. Since each frame overlaps the next one, except for these outside corners, you don't have anything to worry about. 1 inch covered, 1 inch scribed. And pre-fitting all the tricky pieces of stool saves a lot of time too, because now I can just grab this piece of stool and set it in place here, and I'm ready to go. Let me tack that down too. And I'll just tack that in place for a second. I can nail that right down into the top of the frame. And I just noticed something while I was over here. I'm starting to look at this corner. I really don't like the way this stool is going to look coming around this pop-out. I mean, it's going to look clean and neat and everything, but it's going to emphasize the pop-out itself. I think it would look a lot better if we changed this whole design. Don't you think so? I mean, what if this pop-out instead was paneled from the floor all the way up to the ceiling? It's a good thing I never really finished that crown molding, because I'm going to tear it off of there in just a second. And we'll put full pilaster panels on this column all the way up. This layup table works for a lot of different size panels, and the system for pocket screwing the frames together and routing the backs out for the 1/4-inch panels and rabbeting this edge here, it all works really good on top of this layup table. To make this pilaster fit in with the wainscoting design, I'm locating this lock rail at the same elevation as the lock rail on the other frames. I made this rail twice the width too, and I also added an extra inch for the thickness, the height of the chair rail. So the lock rail is going to actually end up balanced above and below the chair rail. Columns and pilasters can be built just like cased openings, with one as the door jamb and the other side as the casing. At first, this job confused me. All the angles in the entry, dining room, and hallway made it tough to understand which side was the jamb and which was the casing. The first thing I did was draw a plan view of all the pilasters. That way, I was able to determine the lines of each cased opening and identify the jambs and the casing for every pilaster. We used this drawing on the job site. The rough framing on the pilasters varied considerably, but we made all the pilasters the same size. To be certain the plinth, astragal, and crown details all lined up horizontally, that everything was level from post to post, we shot control lines with a laser before assembling the panels. Just like installing wainscoting, we used those lines to make sure that the tops of all the bottom rails were level. Once the panels were installed, all the moldings had to line up. The floor was at a level 1.25 inches from one end of the hall to the other, but the tall plinth at the base of each pilaster hid that irregularity. In this home, we used laser control lines to install the windows and doors too, not for the chair rail, but for the continuous band above the doors and windows which ran around every wall in the home, even across the mantelpiece. This time, because the corner frames have to touch the wall from the floor all the way up to the ceiling on both sides of the pilaster, I have to install the corners first and then scribe the long panels on both sides up into the corner. We've already scribed this panel to fit against the corner frame, but we'll have to scribe this one underneath the window all over again. But like I said, the system I explained of subtracting 1/4 inch from all inside corners and adding 1/2 inch for all outside corners allows you to change the order of your install right on the job site to suit whatever happens on the job. I tacked this frame to the corner up here to the wall, but I didn't shove it tight against the corner. I left it about 1/4 inch from the wall right here. I don't know if the top is hanging out more than the bottom or vice versa, or if the wall's out of plumb this way or that way. With the panel away from the wall, I have some wiggle room, and it's going to be a lot easier to set up this scribe. First, I'm going to put my level on this wall and check that it's plumb, and it's not too bad in this direction. So I can measure how far the frame is hanging past the corner right up here. It's tacked here, so it isn't going to move. It's 1.5 inches from the corner right there. So that means I've got to make this thing parallel at the bottom. So I'm going to pull the frame out from the bottom so it's 1.5 inches away from the corner there too. There we go, exactly 1.5 inches. And now I can tack it to the wall down there too. And now I'm ready to scribe this thing. This frame's going to rabbet into the end frame in the same direction we installed the frames before. Remember, this frame here went past and covered this edge entirely. That means that this frame must be at least 3/8 of an inch proud of this corner because it's going to fit into the rabbet on this frame here. So it needs to be proud of the corner 3/8 of an inch. When I'm finished, you know, I think I'd rather have it about 7/16 just to be safe. If I make it too short, it won't fit tight against this wall and it won't come up snug against this panel on the corner. So 7/16, as a matter of fact, I think I'll make it a 1/2 inch for the first scribe, and then I'll dial that measurement in once I have the corner scribe to fit. Right now, remember we have it hanging past 1.5 inches. And if I want it to be a 1/2 inch proud of this corner when I'm finished, I need to remove 1 inch from this back stile, which is how far I should spread my scribes. But I need to also remove 3/8 of an inch from this leading edge to make this stile match the other corner stile. So I'll spread my scribes 5/8 of an inch, and all of the stiles will be kind of balanced. We'll talk about that more in just a minute. I'll spread my scribes 5/8 of an inch. And scribe our way right down this panel here. Fortunately, I used a 4-inch stile back here. Look how much I have to take off. I mean, it's quite a bit. It's almost a 1/2 inch. I had to use a 4-inch stile because the lower frame is going to cover this one. Yeah, there's going to be a little imbalance between the two, but you know, sometimes you have to learn to cope to things with your mind as well as your jigsaw. Let's check this out and see how it fits. Very nice. That's going to be perfect. So I'm going to take this leading edge off of this one now, the 3/8 of an inch we're going to take off of this edge, and then I'm going to rabbet it while it's laying down on my bench. Now we're ready to put this in. That fits very good. Let's make sure we got these up at the right elevation and that they're flush. Yep. And this one looks like it's a hair high. Oh, that shim's cockeyed. There we go. I'm just eyeballing this line around here to make sure that we're relatively the same height. And I'll tack this together. I'll get a little ladder here. Put a piece of crown molding on here. And to make it look even more like a pilaster, we'll take this piece of picture molding right here and put that on beneath the crown, say about, well, let's leave a nice even reveal right here of about 4 inches. So I'm going to put a nail in there, and then I'll take my square and we'll put that right at, we'll make this even. It's about 3.5, 3.5. So we'll shoot that on. And if we keep an even reveal right here, that should look pretty good. There we go. Now we can put these panels back in. Now this is the only one that we're going to have to scribe again. Remember? Because before this one went behind this panel, and now it's going to sit on top of it. So this style is going to be 4 inches right now. We're going to want it to be about 3.5. And if we scribe the end of it off, which we're going to do, I'll spread my scribes to see what's hanging past this end here. And I'm going to go right to the edge of this scribe because we already cut this end right here. We'll take about that much off and run our scribes right down here. Get a little more lead out of there. Perfect. Now let's not forget we've got to cut this piece of stool again too. So it's a little too long. I'm going to spread my scribes once more to figure out how much to take off this back end. And this is what we'll cut off the miter right there. And we're not measuring anything here. We're using our scribes to make sure that we don't make some kind of silly measurement mistake. I'll cut this off in the miter saw real quick and I'll be right back with it. There we go. Perfect. Let me tack that in place. And I'll nail all this in permanently later. And all we have to do is continue this chair rail all the way around the corner here, and we'll have completed this section of the wainscoting and a classical pilaster. That's what we've done here. This pilaster, with the wainscoting coming up to it now, and the chair rail running across it, is a perfect representation of a classical dado. Wainscoting is often called dado molding because that's the architectural term used to describe a tall plinth or pedestal on a classical column. And you see how the base of this pedestal, which is this entire area here now, comes right up to the top of the chair rail. We've made a true dado.